third hour was that most people flew through the degrees. The degree stuff isn't that big of a problem. It's when you get to the radians. And what I want to try and keep bouncing these things off of for you guys so you understand where everything is coming from is remember that sine is what over what as far as ordered pairs are, or not ordered pairs, yeah, that's what I'm thinking of, y over r. Cosine is x over r. Tangent is y over x. Okay. Now as far as the inverses are concerned, that's easy to come up with. Yeah?
I thought like it was really easy to do radians once you figured out that you could just sort of count it back and do like either pi or 2 pi, so like for 54, just kind of back to 8 pi or 2 pi, so it's just pi or 4.
Correct, and that's the whole idea. And being able to do that and work with those reference angles, what we were doing, finding those coterminals and stuff, that's exactly all the prior stuff that we're working on is used here. The other thing, one second, Shay, I'll get you 1 second. The other thing that I wanted to try to show you guys another method of getting these solutions a little bit easier, a little bit quicker, a little bit more structured, if you will, is again to kind of bounce it back off of the special right triangles. 30, 60, 90, 45, 45, 90. We all know those patterns. We all know those values because you've been using them for a couple of years now. Example, when I'm at 30 degrees, opposite to 30 is what? We're going to use what though? 1. 1, good. I'm going to use 1, opposite to 60 is? Opposite to 90 is? So if I want to figure out what the sine of 1/2 is, the sine of pi over 6, I know it's opposite over hypotenuse, 1/2. If I want to find the cosine of 30, cosine of pi over 6, root 3 over 2. I can do those things because I can draw anywhere I want at any point in time a very small triangle and work it through. Drawing up a whole first quadrant grid and bouncing all of your stuff out of those ordered pairs sometimes can be a bit cumbersome. This is a little bit quicker to work with. Okay? When I'm at the 45, 45, 90, what are my ratios of my sides? 1, 1, root 2, yeah. Okay? Then obviously we would still rationalize our stuff out. So as we get into these things, the idea of being able to build your first quadrant with your 30, 45, and a 60, or pi over 6, pi over 4, or pi over 3. As you're building that one out, you're still using the same premise of your opposites and hypotenuse and opposites and adjacents and all that kind of fun stuff via the right triangle and special right triangles. So I want to spend some time going over these things again, and I've got another practical way of setting these things up that tends to help students not so much, it will help you now, but it's going to really, really help you a lot in pre-calc because it's the way that they show these methods of setting these things up in pre-calc. And when you get into pre-calc, you have to be able to do these things like that. And they do time tests on you. It's fun. Miss Shay, you had a question.
You probably said this but so for the inverse, the signs stay the same, you just flip them.
Flip the fractions? Yes. The sign, the positives and negatives, those will stay the same. They just flip the fraction. That's all it is. Now, before we get going too far then, is there any questions as far as the degree measurements are concerned? Are we okay doing and working with degrees? Yeah. All right. Let's start looking at the radians then. Again, as I'm doing these problems, I'm always going to kind of draw up my reference, draw my angle, figure out what quadrant I'm working with. That way, finding the reference angles can be even easier. 11 pi over 6. It's pi over 6, so which quadrant? I'm almost at 2 pi. What's that?
Oh, I was just finding the reference.
Oh, yeah, you're okay.
Skipping that.
Yeah, no, you're fine. You're right. Your reference angle is at pi over 6. Now, if I want to build this off of a triangle, let's show this method a little bit today. People have been pretty happy with this one. Is pi over 6 the 30 degree or the 60 degree?
30 degree.
It's the 30 degree. So opposite the 30 is 1, opposite the 60 is root 3, opposite the 90 is 2. And if I'm taking cotangent, cotangent is the inverse of what? Tangent. So the inverse of tangent. So tangent of 30 is 1 over root 3. Therefore, what will the cotangent be? Root 3. Now, the only thing I have to worry about now is, since this angle is in the fourth quadrant, are both values the same sign SIGN in the fourth quadrant?
No.
One's positive, one's negative. Therefore, cotangent will be? There's your answer. You were real happy about this earlier when you came in, so that makes me, that's good. You got this. All right. Same thing. Did you guys pick up on the pattern that anytime you see something over 4, what's the reference angle going to be? It's always going to be a pi over 4. It's always going to be a pi over 4. And what's nice about pi over 4 is that it's the same for your sine and your cosine, root 2 over 2. It's just a matter of where it's being placed. So as you go through this one, 9 pi over 4, that's a quarter more than 1 pi. So if I'm looking at 9 pi over 4, I'm doing the secant. The secant is the inverse of which trig function? Cosine.
Wouldn't it be a quarter more of 2 pi?
Yeah.
Oh, I was thinking, I thought it was 7. I thought it was a 7 or something. Sorry. Yeah. Yeah. There we go. First quadrant. Even better. Sorry about that. You know, I did the same thing last hour too. I did it for this. I think it's the same problem. Let's see. Secant is the inverse of what? Cosine. So if I'm looking at it, you could do this one of two ways. You know you have a 45, 45, 90. Now, the cosine would be 1 over root 2. What would the secant be? Is cosine positive or negative in the first quadrant? So what is secant? Positive. And you go to the next problem. Okay? Oops. All right. Negative 5 pi over 6. It's almost 1 pi. And it's going the other direction. We're stuck in the third quadrant. Do we agree?
Yeah.
Okay. Now, is sine positive or negative in the third quadrant? It's going to be a negative, so I know my answer is going to wind up being negative. What's my reference angle? Yes. Oh. So again, if I'm going to draw my triangle, pi over 6 is the 30. Opposite over hypotenuse is 1/2. So the sine of negative 5 pi over 6 will be? Negative 1/2. Have any of you guys tried to do it off a triangle yet?
Yeah.
Isn't it easier?
Yeah.
What's that? We won't always have the chart in front of you. Being able to create it off a triangle is just the easiest way to do this stuff. Okay. We can build charts, we can build first quadrant, and it's not that bad. But if you have to fall back upon something you already know, hey, falling back into a triangle is easy. All right. Pi over 3. So we have 5 pi over 3. How far off of the x-axis is it? It's pi over 3 away. So that's the 60. And I'm talking about cosine. Cosine of 60, I can reuse the same diagram, is adjacent over hypotenuse, which is? Now, cosine in the fourth quadrant, is it positive or negative?
Positive.
Positive. So your answer is 1/2. Daisy, I heard you say wait. I thought you said wait. Good, then I didn't hear you say that. All right. '56, I think, was positive. It was positive because you were in the fourth quadrant.
I kept, instead of putting in the fourth, I was putting in the third accidentally.
Oh.
Like, for all the ones that were in the fourth, I don't have to put in the third.
But
I
you-
accidentally forgot to see it was half or something.
If you're doing that, do me a favor when you're finding your stuff, when you're figuring that out, subtract it from 2 pi or subtract it or take pi away from it by using the fraction without trying to, that way it alleviates you from having to use your brain. So if I know, if I know that 3 goes into 5 once and there's 2 left over, that means it's a little bit more. Sit there and write that out as 6 over 3 minus 5 over 3, and you get 1/3, and there's your pi over 3 reference. If it was down over in the other one, if it was 4 pi over 3, if it was 4 pi over 3, that means it was just a little bit more than a pi. So if I subtract out a 3 over 3, I get a pi over 3 over here, but I'm in the 3rd quadrant. So that'll help alleviate which way you're going.
Yeah, I think.
All right. Wait. Negative 17 pi over 6. 6 goes into 17 how many times? 2, but how many are left over?
5.
All right. I'm going the other direction again. Goes in 3 times. So here we go. 1 little, 2 little, 3 little pi. And how much was there? 5, 6?
It's less than 3.
Oh, yeah.
Yeah, it's less than 3. You just want
It's,
I know that. I didn't even do it. You guys are crazy. I didn't even try it yet.
it's
All right. 1, 2, 3. Almost 3. What's the reference angle? Pi over 6. Thank you. So I have a pi over 6 reference angle. Oops. When you're pi over 6, what is your?
30.
It's the 30. Did you guys also pick up on that pi over 6 is 30, pi over 3 is 60?
Yeah.
It's opposite what you think it should be. And I have to deal with the sign again. Sine of pi over 6 is 1/2. But I'm in the 3rd quadrant, so my sign value is negative. Very good. All right. Secant. Secant's the inverse of what? Cosine. Secant is the inverse of cosine. 6 goes into 23 how many times?
3 times.
3 times. With how many left over? 5. 1, 2, 3.
It goes 3 and then it's
I was trying so hard.
You would be failing a test right now.
I am failing miserably, aren't I? So yeah, it's almost 4. Hi. But, or am I doing this on purpose?
No.
No,
Screw you all. At least I got the reference angle right.
For once.
Hey! Easy, killer.
Hey, you could reference angle's easy. It's always just pi over.
All right. Now in this case again, we're 4th quadrant. Is sine positive, or excuse me, is cosine positive or negative? Cosine will be positive. So the cosine of pi over 6 is √3 over 2. But now what do I have to do? Flip it. So this becomes 2√3 over 3. Okay. When you flip it out. And sometimes people, instead of writing it out as √3 over 2 to start with, if you know that you're doing your cosecant, or excuse me, if you're doing the secant, that is going to be your hypotenuse over your adjacent. You could write it automatically as 2 over √3, and then just go 2√3 over 3. Either way is just as easy. Bless you. Okay. Are we getting these?
Yeah.
It's scary, isn't it? See what happened? Did you see how much time you've spent on this stuff? Cosecant is the inverse of what?
Sine.
Yep, cosecant is the inverse of sine. 3 goes into 17 5 times, and there are 2 left over. See if I can do this correctly. Probably right. 1, 2, 3, 4, 5. 2/3 is here.
No, it's not.
Why am I screwing this up today? I'm usually really good at this.
Yeah, it is.
Hold on.
Yes,
that was
it is.
right.
1,
That's 2/3.
2, 3, 4, 5,
And
2/3. Yeah, yeah.
I was vouching for you.
Thanks, Willis. Hey, you know if something's going wrong with Willis is backing me up. But that's okay. Again, reference angle. What are you left? Pi over 3. Good. So you're looking at a pi over 3 angle. You're working with cosecant, so it's the inverse of sine. Is sine positive or negative in the fourth quadrant?
Negative.
Which is it? All right. So the answer is going to be negative something. When I'm working with a pi over 3 angle, I'm working with which one? I'm working with the 60. Yes, ma'am.
Okay, so do you just have to memorize which quadrant they're all? Never mind.
You don't need to, because if you remember this, Shay, remember it goes cosine, sine? The ordered pairs are cosine and sine.
That part.
Remember how we write cosine is x, sine is y?
Oh, yeah.
Yeah, so if you just remember that this is your cosine, and this is your sine, as you're walking around, whichever one you drop into, that's how it goes.
Oh,
Okay?
and then tangent is just that.
Yeah, if they're both the same sign, it's positive. If they're opposite signs, they're negative. Okay. Cosecant. Cosecant is the inverse of sine, so it is hypotenuse over opposite. So this is 2 over root 3. So it's 2 root 3 over 3. And then last but not least,
Wait. Hypotenuse over
Bless you.
opposite. No, thanks. For 30. Oh, 60. Okay.
for cos, I said cosine, didn't I? I meant cosecant. Sorry. I did it right.
Yeah.
And then cotangent. Let's not even draw this. Cotangent is the inverse of what? Tangent. The fraction, the denominator we have here is a 1. What does the reference angle have to be? What is the sine and cosine value of pi over 4? They're both root 2 over 2, correct? So if you have root 2 over 2 and root 2 over 2, what's the tangent going to have to be? It has to be 1. If you think about what it looks like on a triangle, if you're at a 45, this is a 1 and a 1. Opposite is 1 over 1. Opposite adjacent. Cotangent, adjacent over opposite. It's still 1 over 1. The only thing we have to be concerned with here is which quadrant does this wind up in. That's all you have to know here. Tangent of anything that is a pi over 4, your answer is either going to be 1 or negative 1. So if you have no idea how to do the problem, guess. It's either going to be 1 or negative 1.
No.
4 goes into 13. How many times?
Well, no, 3.
3? How many left over? 1. All right. Oh, we're going the other direction. I was going the other way. I don't know what you're talking about. 1, 2, 3, a quarter. What quadrant are we in?
Second.
I'm in a second quadrant. So, is tangent positive or negative in the second quadrant? Negative. So your answer is? Okay.
There's smart board. Looks like you need like a.
It's just when you slap. When I snapshot these things. Now, the one thing that wasn't in this grouping that we have spent a lot of time on is the following. What's the cosecant of pi?
Wait,
1 over pi.
1 over pi.
So that'd be 180.
Okay, come on, guys. One of the things that we haven't spent a lot of time on is as we're writing out some of the quadrantals again. Redraw this up for me. I just did already. What I want to look at here is a revisit of the quadrantal because these guys are going to help you build everything as we go into this a little bit further. What I want to look at here is we start at 0, go to pi over 2, pi, and then 3 pi over 2. Those were the quadrantals. That gets us around 1 revolution. Everybody agree on that? Okay. Now, your ordered pairs for these things is some value x and some value y. And what I want to do is rewrite these things in terms of x, y's, and r's again. And try to see if I can show you, see if you guys pick up on a nice shortcut. When I'm on the x-axis at 0, what is the value for y? 0. Y is going to be 0. What is the value for x? Just x. I don't know what it is, it's just x. When I'm at pi, 180, again, my value for the y is what? 0. What? And negative x, good. Now, whenever you're on the x-axis, what is the value for r? X, very good. Your value for r on the x-axis is always x. Now, does it become negative x on the left-hand side? Why not? Very good. Now, going for the ordered pairs on the vertical. 0y and good. And what's the r value? Now, I want to show you a little trick here. What's the coefficient for x? 1. What's the coefficient for y? Okay. So if I just want to say that this is 1, 1, 1, 1. This is positive 1, 0, 0, positive 1, negative 1, 0, 0, positive 1? Excuse me, negative 1. Are we okay on that?
Yeah.
The r value is always 1?
Yeah.
All right. Cosecant of pi. Cosecant is the inverse of which trig function?
Fine.
Sine. Sine is which value in the ordered pair? Even when you have an ordered pair, what is it? It's y. What's the value for y at pi?
0.
So what's the cosecant of pi? Undefined. Very good. Again, cosecant is the inverse of sine. The sine of pi is 0 over x, which is 0. The cosecant of pi is the inverse of that, x divided by 0, which is undefined. Now, what I'm doing here is I'm kind of shortcutting this by saying that the x values are either going to be positive or negative 1, depending upon where they are on which quadrantal, pi or 3 pi over 2. So it would be x is negative 1, y is negative 1, respectively. X and y on 0 and pi over 2, I'm calling those both 1. R stays the same. Yeah?
Are they going to make this find like a cosecant of 40 or something?
Not yet.
So they will.
Eventually. Well, it's not going to be of 40. What you're going to wind up finding, we're going to do this, I believe, somewhere in the middle of chapter 14, is there is a formula to find cosine of pi over 8. There's a formula to do that because isn't that half of pi over 4?
Yeah.
There's a way to do that. It's not what you think it's going to be. It's not going to be root 2 over 4 or anything like that. There's a little bit longer of a formula to be able to set that up. But we will look at that. You're not going to get something like 80. It should be a, yeah. It'll be a fraction of a 30, of a 45, or a 60. One of those 1/3, 1/4, or 1/6 type thing. Does that make sense, Scott? We'll get to it. But it's all based off of this stuff. Again, What about if I say, what is the cosine of 3 pi over 2? Cosine of 3 pi over 2, think about your ordered pairs again, guys. These ordered pairs that we've written out, 1, 0, 0, 1, negative 1, 0, 0, 1. It's just 0. What is the x coordinate at 3 pi over 2? 0. So what's the cosine of 3 pi over 2? 0.
Oh.
Okay? What this is eventually allowing us to be able to do is the following. This is 1 revolution. Do you agree? The amount of time it takes to go around the circle is 1 revolution. In other words, the amount of time it takes for something to cycle through is called the period. Okay? What we do is we take this rotation of a period of all the different ordered pairs, and we turn it linear. When I start my rotation, we start at 0. You go through 1 full rotation, where do you end up at? In terms of pi, it's 2 pi. 1 rotation takes you from 0 to 2 pi. Along the way, you run into pi, pi over 2, and 3 pi over 2. Do you agree? 90, 180, 270, 360. When I'm starting at my cosine value, if I start at the cosine of 0, what's the x coordinate for it? What's the cosine of 0?
1.
1. Oh, because x is 1.
Cosine of 0, take a look what that means. That's x over r. It's 1.
There's some x going on.
The x.
What's x divided by x?
1.
No, x
And x
divided by
equals
x.
1, so I'm just
Right. What's the cosine at pi over 2? What's the x coordinate at pi over 2?
1, 0.
0. What's the x coordinate at pi?
Negative.
What about at 3 pi over 2? So what's happening is you get this oscillation between positive 1 and negative 1. At 0, it's here, goes here, 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 and here. And you get this curve. This is where sine waves, cosine waves, tangent curves all stem from. They stem from the circular rotation of the unit circle placed linearly on a graph in terms of what they call the period, how long it takes to get around. All right, this is where all this is heading us to. The other part of what I wanted to go over today is this other chart. This.
Oh.
Thank you, sir.
Of course.
That looks.
Yeah, I wasn't going to make you write this down. And what I found over the past few days is that most people are really starting to understand where all these values are coming on, especially when we're dealing with the special triangles. It's a little bit clearer for most people to visualize with the triangles. Yeah, Gunn. I thought you had your hand up. I'm good. I want to help you anyway. Now, here's what I'd like to look at. Obviously, I didn't get a chance to put this whole thing in here, so just bear with me.
Don't get a photo, David. Stop.
Now, when we're looking at this, what I want you guys to see is that on here, yo, no free, what's up, man? On here, you'll notice there's 2 special right triangles on the upper right-hand corner. Which one is which? Which one? Okay. What I would recommend.
Is this 2017?
What I would recommend you do is you fill in your special right triangles. Down below, you will notice 3 grids. 3x y-axis. On one of them, I would draw out my first quadrant in degrees. The next one, I would draw out my first quadrant in radians. And the last one, I would place and put my quadrantal information on it.
What do you mean?
90, what, 90, 180? Yeah, 90, 180. You can put that on there too. Might not be a bad idea. In with one of those. What I'm saying here is on one of those three, I would probably put my ordered pairs for my quadrantals. That's what I need for that one.
What are they?
Okay? That way you know where your 30, 60, 90s are, your 45, 45, 90s are. And here's where this is going to work. This chart is something that they use a lot in pre-calc. It's the exact same chart they use in pre-calc. What they do here with your degrees is they put one at 0, 360, 30, yeah. And then fill in whatever your radians are for all of these. You know what, I put the 360 at the bottom. It'll probably just as easier. 0, and then put 360 down here. That way you know it's flowing through one full revolution. Now, with the sines and cosines, one thing I want you to change. Oops. One thing I want you to change. Where it says cosecant and cotangent, I want you to flip-flop those. What I want you to put it, yeah, you know how we've always gone sine, cosine, tangent, cosecant, secant, cotangent?
Yeah.
Just do it that way. Just change it to cosecant, secant, cotangent. All you have to do is flip the cosecant, cotangent. They put them in like working your way up and working your way down. We've done it this way all along, so I just didn't get a chance to change that before I ran these off. Okay. Now above the sine, cosine, tangent, all that stuff, you see two other small boxes there. One of those boxes, I would write in my sine as y over r, opposite, hypotenuse. And I would do that for all of my trig functions. Because now you have enough information with everything that we've been working on to build this table. Because eventually, I don't know, maybe next week sometime, I will give you a blank one with parts of it filled in and say, you have 4 minutes.
4 and a half.
Okay?
How about
It's twice as much time as you'll get in pre-calc.
Is it?
Actually, they get about 30 seconds.
Is it adjacent over opposite or opposite over adjacent?
But there's
Which
stuff.
one?
But there's stuff.
For adjacent. Opposite over adjacent.
It's opposite or adjacent, yeah. I want to take a little bit of time, fill this out now, and then I'm going to show you some tricks that you can do with these things. Here's what this stuff should be starting to look like. As you guys are going through this, hey guys, as you're going through this, if you know sine and cosine of 30, 45, and 60, everything else falls in real fast. Sine of 30, 1/2. Sine of 45, 1 over root 2, root 2 over 2. Sine of 60, root 3 over 2. After that, they just flip them. When you get to your quadrantals, remember, that's just using ordered pairs. If I am at 0, the ordered pair at 0, we want to write it in here somewhere, is at 1, 0. The ordered pair at 90 is 0, 1. At 180, -1, 0. 270, 0, -1. If you use the ideas of x's and r's, or x's and y's, and r over x, and all that kind of junk, setting up whether or not sine is 0, sine is 1, undefined. It's very simple. For example, the sine at 0, well, what's the y coordinate there? 0. What's the x coordinate? So it's the cosine. And so on. Cosine of 90 is 0. Sine of 90 is 1. Cosine of 180 is negative 1. Sine of 180 is 0. Cosine of 270 is 0. Sine of 270 is negative 1. 2 pi mirrors 0. Yeah, Melissa.
Is it undefined if the y is above the 0 or below the 0?
If 0 is in the denominator, death. That's where it's undefined. Okay.
0 is not.
0 is the denominator. And then after that, it's just a matter of filling everything else in. Your inverses. Remember, the inverse of 0 is, the inverse of undefined is?
0.
Okay. I want you guys to finish this one out, and then the other problems were, I have 8 more of those trig ones you were working on like last night. On page, bless you, page 958.
Page 958.
Yeah. 35 through 42.
35 to 42.
Yes, sir.
That's a lot.
Wait, is change it like sine over cosine?
I'm sorry, what's that?
Is change it like sine over cosine or cosine over sine?
Well, tangent's y over x. Which one's your y value?
Cosine.
Which one's your y value?
Sine.
Sine. That's sine over cosine. Okay? Work on this stuff for tonight. We'll build